Hello, everyone. Today I'm presenting FOCIL, which is our inclusionist design that we're proposing to be implemented into Ethereum protocol via ERP 7805. So you may have expected Thomas here, who is the lead on the FOCIL project, but unfortunately he couldn't make it. So I'm Julian. I'm one of his teammates at the Robust Incentives Group at the Ethereum Foundation, and I'll be presenting our joint work with Thomas as the lead, Francesco, me, Barnabe, Terence, who is here as well, Jacob, and Jihoon. So first of all, I'll give a bit of a high-level introduction to what are inclusionists and what are we actually trying to achieve here. So the inclusionist design philosophy is that Ethereum has access to centralized agents and decentralized agents, and we want the decentralized agents to have some input into centralized block construction. So inclusionists really leverage the decentralization in the validator set that we've gotten from proposer-builder separation, and it's the first design of its kind to do so. And having inclusionists is necessary to obtain the core property of Ethereum, which is to provide chain neutrality. Chain neutrality we define here as any valid and pending transaction that pays the prevailing base fee is included within the block unless there is no space anymore. So the basic idea of inclusion list is that there are some list of transactions that constrains how a block is created. And usually you would say that this list of transactions must be included in the block in some way. FOCIL doesn't change this basic idea. It's more about who creates the list and how is the list enforced. So what is FOCIL? FOCIL is fork choice enforced inclusion list. So the fork choice enforced part says something about how it's enforced, and FOCIL allows multiple validators to provide inputs into block construction, achieving this core property of increasing the credible neutrality. So here you can think about censorship resistance, whether this is for transactions that are being censored because of regulatory reasons, for economic reasons, or by chance, as happens today. And then there are some other design goals, which is robustness of the system. We want FOCIL to be used, and we want it to be only used to provide these, this increase in credible neutrality. And another design goal is extendability. So we want FOCIL to be very future compatible, yet we need inclusionists today, since block construction is so centralized. So FOCIL is a recurring architecture that we see in multiple designs that we're considering for other use cases like PRDAS or other economic benefits. So now I'll go over on a more specific level how FOCIL actually works and how these inclusion lists are created, distributed, and enforced. And later we'll do a bit of a recap again. So I said that FOCIL allows multiple validators to provide some inputs into block construction. In this EIP specifically, we're saying that there are 16 validators that are randomly selected every slot to become inclusion list committee members. And what these committee members do is they each propose a single inclusion list by themselves, and these are then later aggregated into one complete one. So committee members, they observe the mempool and see transactions in whatever way that they see them, and they construct their local inclusion list, which is a list of transactions that they sign over, which is then distributed. And each inclusion list is at most 8 kilobytes, which should be around 20 transactions on average. So 20 times 16 gives you 320 average transactions over all of the FOCIL inclusion lists. And a block on average has about 200 transactions. So we allow FOCIL to be used as like a block template. All transactions in principle could be included via FOCIL, with some extra overlap because these agents the inclusionist committee members might not be coordinated agents, so they may choose similar transactions, so there needs to be some overlap. So now that these agents make their own inclusion lists, these inclusion lists have to be created, and they need to go to the proposer who needs to include them, and the attesters who enforce them via the fork choice. So first we'll look at how these inclusion lists are distributed to the proposer. Each IL committee member distributes their inclusion list over the global topic. This is the peer-to-peer part of the network where all participants listen to. Attesters who enforce the inclusion list, which we'll see in a bit, freeze their view of the available local inclusion list at second 9. So what they do is all inclusion lists that they had seen before second 9, they will enforce. And inclusion lists that come in later, they do not enforce, but they still propagate them to the block producer. And this is essential because this time difference is there to prevent split view attacks. A split view attack is when an inclusion list committee member is trying to split the view of the block producer and the attester. So the person who has to act on it and those who have to enforce it. You could imagine that if the attesters think that there are more inclusion lists than the proposer, then the proposer can't adhere to the rules of the inclusion list because it simply doesn't know what's available. So we give the block producer 3 more seconds to act on it to prevent the split view. So if the block producer doesn't have inclusion list at second 9, the attesters can still propagate it to the block producer. The block also doesn't have to be entirely rebuilt. Inclusion list transactions can be appended to the block, meaning that it can be done fairly quickly. So then on to enforcement. So I've hinted at this already a bit, and it's in the name, of course, enforce via the fork choice. The attesters enforce whether the proposer did indeed adhere to the inclusion list conditions that were specified. So the attesters only vote for the block if the inclusion lists were indeed adhered. And how it works specifically is the attesters have been listening to the global topic where the inclusion lists have been propagated, and they freeze their view at second 9 of the inclusion list that they're going to enforce. And they take the union of all transactions that they had seen in these inclusion lists and check whether any of these transactions was not included in the execution payload that they received. So they check whether a transaction from the inclusion list was not in the block. If this is the case, they check if the block is full or not. So if the block is full, then obviously you can't include the transactions anymore. So if the tester is happy, so the block contains all of the transactions or the block is full, then the attester votes for the block. If the attester is unhappy, so the inclusion list has more transactions and the execution payload misses a view, then the attester does not vote for the block. So the property that we're getting at here is if the block producer does not adhere to the inclusion list, its block will not become canonical because attesters enforce it. So this is the full FOCIL mechanism. We have 16 validators randomly chosen that make inclusion lists. They propagate them. The block producer receives them. It includes all transactions in its block. And the attesters then enforce that the block producer did, in fact, do this. So the core property that we're trying to get at here is the censorship resistance property. And the idea is that if there's only one honest inclusionist committee member in the committee, it can include the transactions that are most likely to be censored by the block producer and include them in its inclusion list, meaning that the block producer has to include them in the block. If we have a network observation that there's a conservative estimate of 6% of solo stakers, then there's a 63% chance that in this single slot there's at least one inclusion list committee member who's a solo staker. But again, inclusion lists are not only about regulatory censorship, they're very much about economic censorship. There's been some observations of builders strategically underfilling their blocks, perhaps because they want them to be lighter in terms of the bandwidth that they consume, or maybe perhaps because they play some games, or they simply haven't seen some transactions. So inclusion lists are here for all of those sorts of transactions. The idea is that we're boosting the signal that solo stakers provide while not relying on economic incentives here because they complicate the mechanism and it adds a lot of protocol complexity. So now I'll go on to show how FOCIL is designed to be as robust as possible. And robustness here refers to robustness against consensus types of attacks, like the split view attack and equivocation. And it also refers to execution layer types of attacks. So people using FOCIL for other reasons than for censorship resistance, but for example, as a vehicle to extract maximum extractable value, MEV. So first, the consensus layer attacks. We've talked a little bit about the split view, but in fact, there are two split view attacks to consider. First of all, there's the split view that inclusionist committee members ensure that the block producer would have a worse view of the available inclusion list than the attesters. And this is bad, because then the block producer can't produce a block that becomes canonical. So we prevent this by giving the block producer 3 extra seconds in which the attesters have already frozen their view. And then secondly, there's a split view attack that's related to IL equivocation. So you could imagine a committee member signing 2 inclusion lists and sending one to the block producer and one to the attester set, if it would have control over that. And how we prevent any bad things from happening here is we say that if there are 2 inclusion lists, so if an attester or a block producer receives 2 inclusion lists from the same committee member, then they do not impact how the block is constrained at all. So what this means is that if a block producer receives 2 inclusion lists, it doesn't know how to act. Now it knows, okay, I do not have to adhere to this. This is a weird case. It should not be happening. And the testers also know this. So they don't enforce inclusion lists where there are 2. Testers have 4 seconds after the block is produced to receive these inclusion lists. So here again, we prevent the split view. Not enforcing any inclusion lists when 2 are sent is a deliberate decision, because this should only happen either if the node is configured incorrectly or if it's an attack. And realistically, it has the same impact as someone sending no inclusion list. So if you said no inclusion list is enforced. If you send 2, also no is enforced. And the other inclusion lists from the other committee members are still enforced, of course. So then there's transaction invalidation. So transactions in the inclusion list may be invalid at the time that the inclusion list committee member propagated them towards that the block producer must include them. There are 2 reasons for this. Potentially, the inclusion list committee member doesn't know the right head of the chain, so it's building on some other head. And the second reason is that the block producer could include transactions before the transactions from the inclusion list. So the inclusion list committee member cannot possibly know what the block producer is going to do since it acts before, so transactions could be invalid. To prevent free data availability, which is a problem that arose with a previous inclusionist ERP, attesters only check where the transaction could have been validly appended to the execution payload. So if a transaction is invalid, then clearly it cannot be validly appended, similar to how if a block is full, a transaction cannot be validly appended because it would raise the gas limit over the maximum. And inclusion lists are never written on chain. It's only the execution payload that's written on chain. So this prevents free data availability as well. Then if there can be invalid transactions in the inclusion list, this may lead to some games that you might think of. So it could be that someone knows that it will make the block at second 12, and it tries to flood the mempool with transactions that it will invalidate in its block later on, meaning that it floods the inclusion list with transactions that will be invalidated, therefore not really constraining its block too much. So first of all, this is a difficult attack to pull off in practice because usually the MEV boost builders only know that they're the builder close to the 12-second line or maybe even past that. But we have like a defense in debt strategy here to prevent this. So how we do it is inclusionist proposers are free to choose whatever inclusion rule that they like. So they're free to construct their inclusion list however they like. And clients can be an agent for them. So potentially one client prefers the way of creating inclusion lists by priority fee. Others may prefer to make inclusion lists based on how long transactions have been pending in the mempool. And others might use some sort of heuristic that they think is most valuable to create inclusion lists. If people create inclusion lists in various different ways, it's more difficult to attack them. So if, for example, one client includes an inclusion list mechanism that says, I want to make my list based on how long transactions have been in a mempool, just ordered, you'd need to flood the mempool long before your slot, making it potentially a lot harder to know that you can invalidate them. So this is really a defense and debt strategy. It's unlikely that this will happen. The gain is quite limited, but even then, we're trying to prevent it. So then you could think of commitment attacks. So an inclusion list is some way to constrain the value that a block producer could extract. So an inclusion list committee member could say, if you pay me, then I include something in this block. Or if you don't pay me, or sorry, if you pay me, then I exclude something from my inclusion list. So the latter is an extortion attack, the first is an inclusion attack. And this is mainly a worry if there's only one committee member. We try to prevent this by having multiple committee members, making it economically less important, and second, less likely. So then, taking commitment attached to the extreme, you could think of FOCIL as a vehicle for MEV, but we try to prove that this is incorrect. We do this via a concept that we call uncrowdability. So the inclusionist cannot be crowded out by other users than simply providing this censorship resistance property. So we don't want inclusionist proposers to sell their rights to make inclusion lists. We argue that FOCIL is robust against these sorts of MEV boost-like markets that you might think arise if you would believe that it's valuable to sell inclusionist proposing rights. We say that FOCIL is not very useful for this because there are no ordering guarantees. Inclusionist doesn't tell you where in the block your transaction lands. There is no private order flow possible because any inclusion list is publicly propagated over the network in order for it to be enforced. There are multiple inclusionist proposers, which prevent some of the inclusion and extortion attacks that we talked about briefly. And the inclusionist is created 3 seconds before the block producer acts. So the block producer has more information about the external state of the world than those who make the inclusionist have. And this means that no individual inclusionist proposer has the right to include, order, or exclude transactions, which is like the canonical definition of MEV. So FOCIL is specifically designed to be as robust as possible against MEV markets for inclusionist proposing rights. Second is extendability. And here, we argue that FOCIL is a great step in the right direction. We feel that it's very necessary to have some form of inclusionist today, since there are only 2 builders. And we see that FOCIL is a recurring architecture in different products that we're trying, I guess not products, ERPs that we're imagining. And so here I'll present 2 possible extensions. You shouldn't take these as part of FOCIL, because they're not in the ERP, but they are things that could be built on FOCIL without changing the underlying architecture. So first is making some transaction fee mechanism to incentivize censorship resistance. So the design philosophy behind FOCIL is to boost the value or boost the signal of those that already provide censorship resistance to Ethereum in a way that doesn't cost them anything, but it doesn't gain them anything either. Potentially, for some use cases, you want these inclusionist committee members to actually gain something from providing this censorship resistance service. And what you could think here is an ERP 1559-like mechanism where the priority fees are given to those who create the inclusion list, potentially subject to how much they contributed to individual transactions being included. The general idea is to make it a lot more expensive to censor transactions. You could do this via this transaction fee mechanism, and you could also change the way that tips work in Ethereum, potentially by having separate tips for inclusion list inclusion and block inclusion, or by having a conditional tip that was popularized by Elijah Fox, Matt Resnick, and MashPy. And then secondly, we're looking at FOCIL for blobs. So ERP 7805 currently doesn't support blobs, although it could with some small changes potentially. But taking it a step further and looking at full data availability sampling, enforcing inclusionist becomes a bit more difficult because those who enforce it need to know that all of the data was indeed available. They need to know that the block producer could have included all of these transactions. So then we could extend FOCIL with some extra condition where the attesters have a good view of whether the data is available or not to, again, prevent split view types of attacks. The important thing here is that this fully builds upon the architecture that we're proposing within FOCIL. So FOCIL is very future compatible. FOCIL architecture is basis for many more extensions. These are just 2 examples, but you could go crazy with this, and I think it's a very interesting design space. So to summarize, FOCIL allows 16 validators to contribute to block construction, which is currently very centralized and mostly in the hands of 2 builders. The main goal is to increase the censorship resistance of Ethereum right now. And the side goals are to provide robustness against consensus layer and execution layer attacks. Consensus layer attacks, again, being the equivocation split view. Execution layer attacks being crowded out by MEV types of markets. And the second side goal would be to be very extendable. So we want FOCIL to be future compatible and unlock a new field for Ethereum that we cannot imagine now. So the next steps are ERP 7805 is available. If you're interested, please scan the QR code and read through it. We're trying to move towards implementation in clients. And my call to action to you is that please reach out to us if you have any questions about FOCIL. If you think that FOCIL could be used as a vehicle for MEV, so this is the thing that we're explicitly designing against. And if you think that you'd like to use FOCIL on your layer 2 to provide censorship resistance there. So that was it. Thank you very much. And I'll be open to any questions.
Okay. Thank you, and also big apologies for calling out the wrong name. So this is Julian Marr from Robust Incentive Group at the EF. So let's get into the Q&A. Julian, please maybe, oh yeah, feel free to. So the first question, the IL committee introduces for the first time a duty for validators that require mempool access. Are there any concerns with this?
Yeah, that's an interesting question. So currently in Ethereum, validators need to have access to the mempool anyway, because sometimes they, in principle from the Ethereum protocol, they are asked to construct blocks. Most of them outsource this via MEV-Boost, but currently validators have access to the mempool. So now we're introducing some way that this is necessary, I guess. Even if there's a very strict reason why you don't want to have access, you could also just propose an empty inclusion list, and then again we rely on that there's at least one person willing to make an inclusion list. I think this shouldn't be a problem. Validators, if they want, they can run a version of the mempool that's well suited for them. Yeah, so I don't think this should be a big problem.
Next question, how does the validator access the mempool, and how does it select transactions?
Yeah, so I'm not sure if this is like more of a dev side of a question or a research question. Coming from the research side, I'll answer it as a research question, I guess. So how does it select transactions? This could be to maximize some objective function that they have for themselves. Maybe they want to include transactions because they think that regulatory censorship is very bad, or maybe they want to include transactions because they don't want people to mess with how their favorite application works or whatever, for economic reasons. In principle, inclusionist committee members are free to construct their inclusion list as they like. And since there are no rewards for this, there's no reason why you wouldn't, for example, order them by priority fee. On the dev side, potentially catch us later. Terence is here as well. Yeah, I think that will be better to do later.
Right. Next question. Will there be PBS-style marketplace for forming for inclusion lists? It seems to be just another block space consumption design from that perspective.
Yeah, so we're very aware of this, and FOCIL is designed explicitly to not foster such a market for outsourcing. Some key observations here are that MevBoost relies on economies of scale. There are high barriers of entry because of private order flow, and the economies of scale come because it's very difficult to construct a very valuable block. And this makes that it's individually rational to outsource my block construction to some MevBoost builder. For FOCIL inclusion lists, this isn't the case. So constructing inclusion list is very easy because you just select transactions based on some heuristic that you like. They're not that big. I mean, you could include 20 average size transactions, and you don't have any ordering guarantees over this, so you can't run sophisticated algorithms to say what value can I extract from these transactions. You have to commit 3 seconds before the block producer, so doing any arbitrage is basically impossible if it were not already impossible because of the ordering. There's no private order flow because any inclusion list is propagated publicly, otherwise it's not enforced. So this makes it that it's not individually rational to outsource block inclusion list production. I guess the question here is that we're very convinced of this, and we've talked to builders and searchers, and no one has come up with a way to use inclusion list as a vehicle for MEV. If you do find a way, I'd be very interested in trying to contradict that.
Is this proposal compatible with 4-second block times?
So the person who asked this question probably thought no, but I think it's actually very compatible. The interesting thing about inclusion lists is that the timeline doesn't necessarily depend on the block construction timeline. So when inclusion lists are created and propagated, which is the largest part of the timeline, can be completely parallel to block construction. Inclusion lists don't have to depend on the head of the chain. They could be made, for example, in principle, they could be made whenever early, let's say 3 blocks early or something, and then they could still constrain the current block. And since this timeline is very, very easy, as in the block producer must receive them, for which it could have a very long time, and the enforcement is done by the testers, it doesn't add additional time delays. That being said, if you make them very far in advance, the inclusionist is more likely to hold invalid transactions, which may not contribute much to censorship resistance.
Next question, how about the integration of FOCIL with ePBS and single slot finality? They should be aligned coordinately.
So we're proposing FOCIL separately from ePBS or single slot finality. I think this is important because I don't see an inherent tension between these. As I explained in the previous answer, the FOCIL timeline can be completely parallel from other timelines. So in my view, it's very compatible with both, and they don't have to be implemented at the same time. They're proposed as different proposals.
Does it mean transactions from inclusion lists will always be at the bottom of the block?
So first of all, transactions aren't necessarily from inclusion lists. Transactions in the mempool are seen by inclusion lists and then included in the block, but the block doesn't contain a section that's like, this is for inclusion lists. So some transactions that, I guess you could just see them as transactions in the mempool. Mempool transactions currently usually are not put on the top of block because this is a very valuable spot. Maybe someone can extract some MEV from being at the bottom of the block. So I'd expect them somewhere to be in the middle. There are no ordering or properties of where in block it should be.
Should equivocating committee members be slashed?
So in our design, we don't slash committee members. We do this because there is no reward scheme. We want to incentivize as much participation as possible. So slashing could be caused because you have a bad node setup and you accidentally sign something twice. You don't want to do this. You want to prevent it. But if it happens, we don't want to penalize for it. Slashing in a equivocating on your attestations is important for finality, to give some economic weight behind the transactions that land on chain. Slashing for double signing a block already is different. It's not related to finality. But it does cause a bit more stress on the chain. Equivocating with your inclusion list doesn't cause anything. It just means that your inclusion list isn't enforced. It's equivalent to sending no inclusion list. So that's why we don't slash for it.
Right. So unfortunately, we have run out.